and when somebody requests, like if um, you don't have to approve their audio, they just jump in, as I think you know. The If they want to share slides, we'll actually get a pop up saying, they want to share screen. Then we have to let them, but that's not going to happen because we have all the slides. So I'm going to take slide control back because I'm going to do it from my keyboard. Oh, we're at time. All right. We'll give 1 extra minute just because we don't have a super tight agenda and let people trickle in. But otherwise, I'll start the slow introduction. This is the Secure Asset Transfer Protocol Working Group. I assume my audio is okay, Ori? You can hear me? Okay, good. Your chairs are Claire and Wes. Claire unfortunately couldn't make it today. She had a conflict, so I've looped my secretary here, Peter, who is the working group secretary, in to help me chair the meeting today. So this is not Claire. The mailing list is on the screen. It'll come up again in a minute. Everybody should be well aware of the note well because you had to agree to it in order to attend the conference, but essentially it says watch out for how you contribute because it affects intellectual property as you give your statements and things. There will be a new note well coming up soon. It's the IESG has been recently revamping it, and I think it's still sort of in discussion. So this is the old note well still, but probably next time there will be a new one. There's a bunch of useful information for how to participate in the IETF that includes our standards process, our working group processes, important anti-harassment procedures, code of conduct, copyright information, and patents and participation, as well as our privacy policy. Real quick overview of code of conduct. I think everybody at this point knows the IETF well, but we are generally nice to each other. We should speak slowly and limit the use of slang and other things that people may not understand. We use engineering and we try and find the best solution for the entire internet, not just yourself. And we all contribute to the ongoing work of the IETF. I'll remind everybody this session is being recorded. It will be on YouTube rather quickly. They're pretty quick these days. So make sure that you understand that if you're going to contribute. There are 2 ways to join. It's very important that everybody that is participating today join the session, either with the on-site tool using your phone and the QR code, which is in the back of the room. It's no longer on the screen, or you can go to the IETF agenda page. If you're remote, you can also use the full session tool that gives you all the audio and video tools that you might need. And then finally, here is our working group information. So we have a data tracker page, of course, and the purpose of the group, hopefully everybody knows if you're here, which is to develop a protocol to transfer digital assets between 2 different asset networks. We have a mailing list, which is SAT, S-A-T, not S-A-T-P. The mailing list predates the working group name, as happens frequently in the IETF. And we currently have 3 active drafts that at the end of this meeting, my goal is that we will have the schedule to hand it to Ori in the order of weeks. Right, Thomas? Good. Okay. 2 of them are basically done. We have one last thing when I threw a huge number of issues over to Thomas to handle. The agenda today is actually fairly packed. We are in the process of transitioning between wrapping up the last documents and moving on to the next set of work. So we'll go through the agenda one by one later. One point to note is for the process flow, we are still in those 3 drafts are right before submitting them to the IESG. That's where we were last time, but I think we're really about to give them to Ori shortly, who is our area director. That's basically saying the same thing in words. The important thing to note is coming up next after Ori reviews them and gives us lots of complaints, the entire IETF will review them and you'll get more complaints than you can possibly imagine. But at the same time, we can sort of start sneaking into the next set of work. So last time we had a discussion with a long bullet list of all the brainstorming we did, I think 2 sessions ago. And I distilled that after going back and watching the video and looking at everybody's comments, sort of the top work items that we would likely be focusing on based on the comments at the microphone and what I've seen on the mailing list and stuff. So there are sort of 5 out of that longer list of, I think, 14 items that really were the next things that we want to sort of tackle. Certainly, the initial negotiation step, what we've been calling phase 0 in sort of slang terminology and in the working group, is sort of top of mind for everybody. We need to develop a data sharing mechanism, which is really a view into another network. Developing a registry for negotiating communication requirements, and then um, developing the requirements that we're imposing upon a network and a gateway. Is like what is the minimum things that they need to do in even order to participate in this, and get a better enumeration of that list. And then finally, the thing that actually surprised me last time is a lot of people really do believe we should have a solid threat model document, so we make sure that what we're doing is secure, and doesn't have any holes, and the security area directorate can help us out in reviewing that as well. So given that, the agenda for the day actually has a lot of items from that list. So our priority is always, we have to finish the documents first. Anything else falls off. If it takes all meeting to finish the documents, then we're not doing anything else. But that's not going to happen. And then the way I ordered the results of the agenda for the day is based on sort of that list that I just showed you for what I believe that we're really going to focus on next. I've already written the proposed next charter to hand to Ori, but I'm not going to show it to you guys until we get the documents out the door. So with that, I'm going to turn it over to Thomas next, who's going to give us the updates on the core document.
Thank you, Wiz.
You can take the clicker there, and I will make it work in 1 second. Try it now.
Okay, folks can hear me okay? So 3 slides, 3 of the big topics, issues in the repo that we were fixing. So the first thing is network ID. So all over this SATP core, we talked about network identifier, all over the place without actually ever saying it. And so there was not even a text explaining why we're needing this. And so I put some text there describing the fact that a gateway, a service, could be serving multiple distinct unrelated asset networks, and that some form of identification of the asset network is needed. So this is a thing that, believe it or not, I'll use the word blockchain. The blockchain tokenized asset industry has not addressed. I mean, shockingly, there is a draft there, draft Zhang. Weijie Zhang is from the Enterprise Ethereum Alliance. So he and I started working on this. It's expired, so that's one of the things we want to update. The problem is still there from 2 years ago. For those who are interested, just very quickly, if you're trying to do a cross-chain transfer into Ethereum, your transaction might end up in the wrong fork. Okay, well, we can bring it offline if you guys are really interested. So that's corrected that, added text, and just said, look, we don't know what this identifier look like. It has to be alphanumeric and some JSON compatible. It's probably alphanumeric or hex or something like that. But at least we've got a couple of paragraphs explaining what it is. Credentials. So this got me. So even I got confused. So the word credential is used 2 different ways. It's used to describe the credentials needed for a client to communicate with the gateway that's out of scope for us. Say to configure the gateway or to do instructions and so on. So we call that API 1, RESTful API. We're using it there, and we have a little bit of text explaining it. And then we're using the word credential to talk about essentially the TLS setup between gateway 1 and gateway 2. It's okay, this is really confusing. So we replaced that and just called it gateway TLS scheme. So the word scheme is used instead of credential. And you guys know this is the minimum cipher. And we said it has to be, gateways have to support the base cipher and the modes specified in TLS 1.2 and 1.3. Of course, if 1.2 in the future gets deprecated, it'll be whatever the minimum is for 1.3. So that's kind of, so that's a big update. So that's the scheme we've got there. That's 1.2, I believe, and folks can correct me, but cut and paste from 1.2. Um,
So I assume the document says 1.2 or later. Is that
yes,
okay?
in some places I said 1.2, 1.3, but 1.2 or later most of the time. Yeah. Um,
Don't tell me most of the time. It's got to be consistent.
I will fix it. Make sure it's 1.2 or later. This is another one. So we had a whole section on crash recovery and session resumption that's been in the draft from like draft 00, and there is an understanding that we will be creating a separate draft describing at least two ways to handle crash of gateways, primary backup, and you know what is it, the recovery, self-healing. But that is so long, and deserves a separate draft. So the text from SATP core has been moved there, and then also two of the parameters have been removed from SATP core and moved there. And these are what is called access control profile. So basically, this is um, what. Uh, so first of all, logging pro. What logging mechanism is a gateway using to store the relevant messages from SATP locally in the case it needs to recover or and so on. So that's called the profile. And then there's access control profile. How do you access that little database? Now, this capability does not have to be communicated from gateway 1 to gateway 2. Gateway 2 doesn't need to know how what access credential profile is being used by the little database in gateway 1. I mean, why? So that was removed from the initial set of claims. But what we're going to do is expand on this in this draft Belchior. We have a draft Belchior crash recovery that's I think needs a bit of updating. So that's where all this work is going to be done. I think this is. I think
So that also sounds like a good place um, for the requirements to be imposed on a gateway and a network,
that's
right?
right. Yeah,
Okay.
yeah. So yes. So the thing is, for example, a gateway. So gate G1 and G2 are talking to each other. If G2 learns that G1 is using a recovery mechanism that it thinks G2 thinks it's not good enough, it may say, "I don't want to talk to you. Give me another gateway." So that's a possibility, right? So this capabilities exchange needs to happen in stage 0. This is the important stage 0, and so future work. For those who are new, or stage 0 is a setup phase, is probably more polite. If you look at the diagrams, we got stage 1, stage 2, stage 3, and that's we sort of said setup phase is called stage 0. Any questions about SATP core?
Sounds good. So I actually have one,
Yep, please.
which is one of the ones that I think I hinted in my long write-ups of things for you to think about, but I didn't do. So one of the things that IETF documents have to do is decide what things need to go into the specification, in terms of enumerated values. And I know you took care of all of those, and what things should go into a registry. And I know we have a registry now. The one outstanding one that I didn't want to touch because it was too much of a shuffle until everything got done was all of the error codes are currently in an appendix.
Yes.
And I believe that they likely need to be agreed upon values because you're passing them back and forth where the
Yes.
other side needs to do. To me, I mean, so I guess what is your thoughts? Do you think?
So is it the norm to put it in an appendix in an RSC, or is it should be part of the body, like the last section,
Uh, um,
or should it be put
Actually,
in
it's
a
a good question
registry?
for Ori. I would typically put it in a registry because I would expect other documents to add to it.
Okay, okay, yeah,
But
yeah.
but I don't know. Do we put stuff in appendixes?
Hi, or is still not in the queue properly. But to answer the question, if you have like a full like a schema definition or like a normative structured format API definition thing, you can put that big sort of structured schema document thing in the appendix. But for anything that an implementer must understand in order to implement the protocol, that should be in the body of the document. This is usually my recommendation. So it's fine for it to be kind of described in text in the body of the document and then repeated in some structured large object in the appendix, but don't bury your normative requirements in your
Okay,
appendix.
so that's normative. It's a table. It's a long table, and that's normative. You have to implement. That's the error
Yeah.
codes.
I mean,
Yeah.
appendixes really they're there's no difference between an appendix and a section other than where
Okay,
it occurs, right?
Yeah, like
can move it.
if you feel like it's going to disrupt the reader, you can have a section in the body of the document that says, see the appendix for the complete list, but here are, and
Okay.
then some people like to mark sections of the appendix as normative in those cases to make it extra clear. I prefer for that stuff to be in the body of the document personally, but
Okay.
you'll get comments either way.
Okay, it's there. It's just a matter of like
Right.
where to put it.
But
Yeah.
then back to my other question, do you believe you're going to be adding error codes in the future in other documents?
Yes.
Then that becomes a,
Okay. So registry.
yeah.
Yes. Okay. So you need to help us. I don't know how to put.
No, so I mean, you've already done one registry,
Okay.
but and you can actually go talk to the IANA table.
Oh,
They're
just there.
they're
Okay,
they're here
okay.
all week. They would be
Okay.
happy to have that conversation,
Okay.
especially when you tell them you have 200 error codes or something. I mean, one you might look at would be the HTTP registry, right, which has a large number of HTTP error codes in it, and that's you can see the HTTP specification where they created it and what it looks like, and you can sort of copy it. There's also an IANA RFC that I can't quote for providing IANA guidance in documents that you can look at.
Okay.
But to a large extent, it's not a major work. You just need to move that long list of stuff into into the IANA consideration section, saying populate the initial table with these values, and I need these column number names.
Okay.
That's it. You're just
IANA
describing to
consideration.
IANA, this is the table I need, and then anything else.
Okay. Okay. It's not in the IANA consideration section
Right.
now.
No, it's not.
Okay. Okay.
And
got it.
the very last part of that is you do have to decide what it takes to add new values. So can anybody add a new value? Is it first come, first serve? And there's a whole list in the IANA RFC for what you can pick from. Or, does it have to be a standards document? Because you're using fairly generic error strings, it doesn't need to be super restrictive in my personal non-chair hat opinion, right? You want it to be flexible where
Okay.
implementations, can reserve a value or something like that. You might
Okay.
describe what those names should look like or something,
Okay.
but we can talk about that on the mailing list.
Okay.
So,
That would be good. Yeah.
okay. Haojing?
Yeah. Other than the contents, what you shared in the slide, I have a question about the URN scheme described in the code draft. As far as I know, URN scheme is required for describing the API message type. And
Yes.
yeah, so I wonder if it is just required or recommended in terms of the implementation viewpoint.
I think isn't
Yeah.
this like the message types that
Yeah.
need to be unique?
Yeah.
Yeah. Do we put that in a registry as well? Do we ask? Or is it by the fact that it's got a URI already that it's collision free, so to speak?
That's actually a good question. I'm not a URN expert. Oh, Ori. That's actually something I feel like I should know because I've actually helped with documents, but it was 15 years
all the
ago.
messages have got message.
A URN.
right?
So do they need the prefix or do they actually have to register each? And no, I mean, so you should get authority beyond some point, right?
So, or Steele, if you're asking what are the required prefixes for registering IETF namespace URNs, IANA, repeat the question.
Yeah, no worries. So if they have 12, so they have a URN per message type.
Yep.
They don't need to register all 12 message types. They register a prefix under URN : IETF : SATP.
Yes.
Yeah.
So that's
Yeah.
that was
You would register one prefix for all of those, and then it's somewhere in your document you have to describe why each of these names is necessary, but you only need to register the prefix once.
So that would go in the IANA consideration section as well?
Yes. To register the prefix, you have to go to the registry that the prefix is going to be entered in for IANA, follow the instructions from the IANA considerations for that RFC, which will tell you what are your obligations for adding that prefix to that registry, and you consult the designated experts for that registry.
And that's there now, right? I mean, the URN.
Yes, it's there. Yeah.
Okay.
Yeah.
Thank you. Any other questions for Thomas? Okay.
Thank you.
Thank you. So that brings us to the end of the core update, does anybody else have things that they want to talk about for any of the three documents, which includes the use cases, the core document, and what's the third one? Architecture. Thank you. Before we move on to sort of the other business of future work items. Okay. Oh, I need to steal slideshare back. Then next up, we're going to talk about stage 0. And Dennis, I assume you are online?
Hello, everyone.
Hello, Dennis. All right. I will pass slide control to you. So it should appear on the bottom of your screen, and you can start when you're ready.
Yes. Okay. So do you hear me okay?
Yes, you sound good.
Perfect. Okay. So, yeah, as Thomas said, the stage 0 comes with the SATP registry. And as you will see, there's a few things, there's some examples of the use of the URN as we just discussed. So just to set the context, the stage 0 or the setup stage comes before the execution of SATP as defined in core. In core, basically, we have the transfer of one or more assets between a network 1 to network 2. So it's a unidirectional transfer from one network to the other. And there's the interaction between gateway 1 sitting in front of a network and gateway 2 sitting in front of network 2. The whole idea about the setup stage is to make sure that all the things that have to be negotiated between gateways, the registration of assets, access to networks, all the things that the SATP protocol requires are defined. So with that in mind, I'll switch to the next slide, which probably is too small as I see it now. I don't know whether you could see it because it's really small here. So the intention here is not to go through everything, but at least to guide you through the flow. The whole thing about stage 0 is that there is a client application that wants to initiate a transfer from network of assets that are stored in network 1 to assets owned by a client application in network 2. So indeed, as Thomas is saying also in the chat here, when I have the swim lane about registry, it's the SATP registry. Okay, so the SATP registry is there to record any sort of artifacts that are needed in order for SATP to complete. So that, for example, that might contain one important thing that we call transfer context, which is basically everything that is necessary in order to be able to bind the gateways, the networks, the assets all together to execute a instance of SATP transfer. So examples could be gateway IDs, network IDs, transfer context, eventually definitions of what an asset is, what we commonly call asset profile. So these are all artifacts that are necessary for SATP, and they could be registered in the SATP registry. So the thing that we see here in this flow is that the client application that owns the asset initiates a request for a transfer to gateway 1. So during this whole stage 0, there is the gradual creation of what we call a transfer context. So the transfer context will contain identification of the gateways involved in the specific transfer instance. There would be network IDs. There would be things that could be like sessions, and eventually many sessions if there are recoveries for a specific transfer instance. So as we see it here, there is a sequence of calls. So the client goes to the gateway 1, saying that I would like to initiate a transfer, so I need a transfer context. When the gateway one creates the context, it registers it with the registry, and then the client goes to the network and binds the specific assets to the given context. That might be important because there might be concurrent sessions that might also, have access to the same assets from the gateway to the network. So here there are some things that we can think, like for example, policies that allow a network to choose which gateway actually will win if there are many gateways or transfer instances that want to transfer these specific assets. So that's why the binding is important, because we link the asset with a specific transfer context. Then in number 5, there is a transfer between the client, from the client 1 to the client 2. So
Okay, can
that's
I interrupt?
yes,
David,
sure, please.
yeah, can we let David ask his question, because it's probably in the context of everything you just
Yeah.
talked about.
Yeah.
David, go ahead.
Okay. I have problems with step 5 there. I don't see how it works.
Mm-hmm.
And also, that raises the bigger issue of how do we bring client app A2 into this whole process?
Mm-hmm. So the thing about the propagation of context is the fact that there is this example of Alice and Bob that wants to transfer asset to Bob. So Alice owns the asset and has to, transfer it to a remote application where actually Bob needs to accept the asset. So somehow there should be the transfer of the context, saying that there is a instance that is about to be configured, so we could execute SATP for the asset transfer between Alice and Bob. So the propagation of a transfer context could be anything that will actually bring the transfer context from client app 1 to client app 2.
We're not defining what, as I say, right now, unless at some point A2 registers with Gateway 2, I don't see how message 5 gets from A1 to A2.
Yes.
That's
So
something. And then
okay.
that, of course, gets to the point is, how does A2 know that he has to register with Gateway 2? So
that's how it goes with 6 and 7. So let's continue with the flow there.
I mean, you're expecting 5 to work first before you.
Definitely. So the thing that is about 5 is about the fact that there is Alice that says to Bob that there will be a context, a transfer instance, a SATP transfer instance, where I'm going to send you the specific asset based on whatever negotiation there is between app 1 and app 2. So when the app 2 receives the context, it goes, as you see, number 6 goes to gateway and says there will be a specific transfer context that has been, yeah.
I mean, I assume the way this message goes, it goes from A1 to Gateway 1, then to Gateway 2, and then to App A2. For instance, how does Gateway 2 know to direct that message to App A2?
So let me continue a bit, because before even the gateways get to know each other, there should be Alice and Bob that negotiate this transfer of assets. So if I have, there's Alice that wants to transfer to Bob, they should know each other. Now, the fact that these two client applications talk to each other, it will make it so the gateways get into play, and then the networks too. So the idea here, as you say, as you see in the beginning for the first 5 messages, is that the client app goes to the gateway and request for the context. The transfer context is created by the gateway, signed by the gateway, and registered with the SATP registry. Now, this thing, it is also goes to the network, as you see, number 4, and binds the asset with the specific transfer context signed by the gateway 1. So when the client app goes to Alice, goes to Bob and say, this is the beginning of a negotiation of a transfer. So here is the transfer context. The client app 2 knows that there is the gateway 2, that it will be the gateway for accessing network 2. So that's why there is a validation of context where gateway 2 gets basically is wired with gateway 1 inside the transfer context. First, to check if the assets are valid, and second, to establish the link between gateway 1 and gateway 2 already in terms of the transfer context. Now, if this goes okay and the assets are okay, then there is a binding in number 10 between the client and the network. And when everything, so this is to host the assets that will be put in network 2 when they are transferred from network 1. Now, as part of 11 then, because client 2 knows about gateway 2, it goes and say, now you could propagate the context, so you could effectively make the link between gateway 2 and gateway 1, which happens in number 12. So when everything is established and the transfer context contains both the gateways, the networks, and everything else that is required as part of the negotiation of the transfer, then in number 13, the gateway goes back to the client app and say, now we are ready to execute SATP. So this whole thing about the first 13 messages is in order to set all the components together in one thing that we call the transfer context, which is a data structure that contains all of these things. So once this thing is executed in 14, then the whole core starts, and it completes whether by committing or rollbacking the whole thing.
Are you saying that the transfer context has the information that tells Gateway 2 how to direct a message to client app
Yes.
2?
Yes. And yeah.
Go back one slide, please. So let me try and reframe the question in a different way. In flow number 5, is that over any transport mechanism? In other words, any way that client app 1 knows to talk to client app 2 because they have sort of pre-agreed that I'm using this thing and you're using that thing, and they can, exchange some sort of, they can properly exchange a transfer context, right? So it could be carrier pigeon, it could be some TCP session,
Completely,
or Bluetooth,
yes.
or whatever. Okay.
Yes. So the thing is a data structure that they have to exchange somehow. We don't specify how this thing is going to happen, but the thing that we ultimately want is to have the client app sending this data structure to client app 2. And if I can show the next slide, that's an example of a transfer context. It's a very simplified one, but as we see, first of all, we could see the URN structure. So, okay, which probably would be something like a SATP or IETF SATP, of course. And then there are suffixes, like typically the transfer context itself, it's an immutable ID that refers to the specific transfer context. It never changes. It is there. We could refer to. And as we say, there is a status if it is in progress or completed, of course. The session is that it's an example where the transfer context could have many sessions because, for example, it has been interrupted. We have different sessions and a history of sessions. And the egress part is the one. We see the gateway 1 ID, the network 1 ID, the way to access the network in the network 1 endpoint. And also, there is also the definition of the assets. So there is an asset ID, of course, with a expiration status, day, time. And on the other side, in the ingress, is the number 2 things. So the ID of gateway 2, the network 2, and the network 2 endpoint. So how through this network endpoint, you could access the network. So these are the things that are built, during this setup phase. Eventually, we could add other things, of course, but this is an example of all the things that could be put in a transfer context. And as you could see, all these things about how can you register gateway IDs, network IDs, all of the asset IDs are things that may eventually happen even before the setup stage. So gateways could be registered with the SATP registry, networks also, clients could also, be registering all these artifacts, the assets, for example. So this is something that is not yet specified, but we assume that when we have a setup stage executed, somehow the registries know about the IDs of all these various things.
Okay, Thomas has a question, but Thomas, I want to let him go through to his last slide to make sure that we have time. But you're next, I promise. Why don't you continue to your last slide, Dennis?
Yes. So basically, what we say here is that the registries are like components like gateways, where we could register any sort of artifacts that are required for the SATP protocol. So we could have transfer context, any sort of identifiers for the gateways, for the networks, for the assets. We could even imagine that we could register there the types of the assets, so what we call the asset profiles in some of the internet drafts that we have already published in the SATP working group. So why do we need the registries? Is for two things, just to guarantee the two basic properties of a protocol, the safety, so the things that actually prevent bad things from happening. So any sort of registration of the structure of the components that have to be used during SATP to interact among the various components are used in the registry. So we guarantee the safety property of the SATP protocol. And on the other thing, we could also register things that maintain the state of the transfer instance. For example, if we have different sessions because of crash recoveries, we could use the transfer context to register things there. So they're all in the registry in order to guarantee the liveness property of the protocol.
Okay, Thomas?
So actually, this is more a clarification on that diagram. So what Dennis was talking about, we need a pre-stage 0, but it's completely out of scope because so before we even go to line 1, so the industry today already has a business workflow that arranges what assets moves where, right? And then once they agree, then they trigger something and we enter line 1. Right, and so the client app 1 and client 1 and client 2, app 1, app 2 know how to interact with each other, know who they are, and they can communicate with each other. So this is typical today of the workflow in the CSD, centralized securities depositories today at DTCC in New York. Put a note there. Eurocleared. Dennis was working there for a while, and more recently Clearstream, and so they know how to do this. But for traditional banking, payment that way, shares this way, kind of thing. So we're trying to like edge them forward to say, well, okay, payments this way, but now instead of actual shares, we're talking about tokenized assets, tokenized shares, or tokenized money. So yes, quickly, something happens before line 1. A big something happens before line 1.
I feel like it stages all the way down. So is the registry, which is not currently in the architecture, a required component if the two network 1 and network 2 already have a prearranged agreement on how to do stuff? Is the registry needed? Is it optional?
The registry is there in order to capture things that are important for the execution of SATP. So if we see a bit the structure of all the ongoing discussions, that the networks know about networks only, so themselves. Registries know about networks, and gateways know about registries and networks. The idea of a registry is something that immutably stores things that could always be there in order for the gateways to execute SATP. We could imagine that there is an architecture that this notion of registry could be distributed inside networks or gateways somehow. But conceptually, this concept of registry is, we think, important in order for all the artifacts that are related to SATP to be configured properly and stored immutably before the execution of the SATP transfer instance.
Okay, so clearly we'll need work defining that in the future.
Mhm.
I think with that, a good presentation on the start of stage 0. It's good to see this work, but we should move on to the next agenda items.
Yes. Just one more last comment. It's about the URN, the definition of the URN for SATP. I think this is something important. We have a lot of different artifacts that need to be somehow registered, through this URN, the SATP URN.
Yeah, and the core protocol document. So you should read the core document and what it says now, and we'll see if it's sufficient or not.
Mhm.
And then how you're going to assign components like gateway and network underneath it. For example, your IANA considerations should talk about that. Like these values, these subcomponents are reserved for these usage, and then everything beyond this is supposed to be a unique value, owned by whatever. So,
Excellent. Okay.
Yep.
Thank you.
Okay. All right. Thank you very much. All right, so next up we have state views and addresses by Rama.
Hi, can everybody hear me?
Yes, we can hear you. Back off of your mic a little bit. You're clipping.
Sorry.
Audio is a little hot.
Okay, is it better?
Yep, even a little bit more would be good.
All right, let me try this. Is it good?
Yep, that's good.
Okay, thanks. So, hey everyone, I'm Rama. I've presented this content before, so there's nothing really new I'm going to be talking about today. I just wanted to give a refresher to everybody on the topics of ledger state views and data sharing, which I presented, I think, maybe 3 or 4 times in various IETF meetings. So, can you move to the next slide? So, I just wanted to.
So I gave you
yeah.
slide control, so you should have buttons at the bottom of your screen now. So.
Okay. How do I? All right, got it. Okay. So yeah, I just wanted to motivate the need for standardizing what I'm going to be talking about, which is views and data sharing, and also just flashing some of the concepts that I've talked about in previous meetings. So to summarize, what we're trying to do is, I mean, the first 2 bullets are kind of banal statements. Like every digital asset system needs a way to expose its internal state to external entities, and likewise, as a corollary, external entities need ways to request and validate state coming from these systems. Now, in traditional systems, we have ways to do this, just expose service API. But when systems are distributed ledger networks, especially those that are private or access controlled, it's not just about exposing the service API, because these networks don't have a unitary or a centralized authority. No, there's no spokesperson that's authorized to speak for a network or can be trusted to convey what the consensus state is. And the veracity and the authenticity of state that is shared by such networks are both established and validated by collectors. Especially, I'm talking here about if the external entity itself is a network. So gateways, which we have introduced in the SATP architecture and which we've been using in SATP core to communicate an asset from one network to another, provide vectors for such data sharing. Data sharing is just a way of saying that one network requests data from another network, and it gets it back and can validate and consume that data. But it's just having gateways is not enough. What we've done in SATP core is show how an asset can move atomically from one network to another, but we need something more for state requests to be communicated from one network to another via gateways. Have some sanity check be done on the on the queries, and the queries be translated into something that the network can understand and respond to. And as we all know, the principle of SATP is that the gateways are our first-class actors, and the networks behind the gateways are supposed to be opaque, and they are expected to be heterogeneous systems. So therefore, we need standardized ways to identify or address ledger states that are maintained by collectives. In this case, like a private or even a public distributed ledger network, and the states need to be packaged in a way that can be externally validated and consumed. So, going to the next slide. So on the left, I'm just pointing out that in the architecture draft, we have defined 3 kinds of interoperability modes. So one reason for having the standardizing ledger state views and data sharing is there is an intrinsic need for it. It's one of the modes that's been defined. That's data sharing, or what we used to earlier call, we just call it data transfer. So that is distinct from asset transfer, which we've already worked on, and asset exchange, which we are also starting to work on right now. And there are several use cases under the trade and the finance and the commerce sections in the use case document that motivate the need for data sharing. And so, yeah, would encourage everybody to go and refer to those. There's another low-hanging fruit need for or use for views and data sharing, which is to complement the SATP core protocol as it's currently defined. So in stage 0, which is still in the works, this may be useful for whenever we do any kind of cross-network discovery of network capabilities and asset characteristics. So if you want to do a query to find out what from N1 to N2 to find out what exactly, whether N2 exactly has an asset and whether it has particular properties, then we can use state queries for that. And likewise, if you go down to stages 2 and 3, if there happens to be a crash and session needs to be recovered, then queries can go from one network to another to verify whether or not a lock was committed successfully, or whether, like in stage 3, whether a mint was concluded. So to reiterate what I've said before in previous meetings, view is a term we borrowed from databases. It's just a shortcut for information that's derived from a ledger, and especially significant permission ledgers. It also carries proof of state. That's one of the more important things. So we wanted to standardize the way of packaging data along with proof. And we're trying to define an address by which which will be encapsulated in a view query, and that address will look something like a URL. So have 2 examples from the Hyperledger Fabric DLT and from the Corda DLT, and this is something we have used in code, which is what I'll come to next. So there are some. We have actually implemented this and used this for a while now, more than 5 years at this point. And there are a couple of publications. The first publication, Middleware, talked about, actually presented the taxonomy of the different interop modes, and also talked about data sharing and showed how it could be achieved between 2 Hyperledger Fabric networks. And then in the second publication, we actually formalized the notion of a view, along with some security formalizations as well. We have code as well as specs defined in Hyperledger Cacti under the Weaver submodule, and these data sharing along with asset exchanges and asset transfers were demonstrated in a CBDC use case, which was done in the context of Digital Euro in the year 2021, and this was showcased at the Hyperledger Global Forum in 22. So there are some links there for people to check out. So this is the final slide. What exactly do you want to standardize here? So if you look at the data sharing draft that we currently have, there are 2 kinds of protocols that are showcased. One is the main difference between the top and the bottom is that in the top one, the external, who's querying is representing a unitary entity, whereas in the bottom figure, the query is coming from a network. So that's the main difference. So other than that, what we have is a gateway gets for the network at the right gets a view request, and it must communicate that to the network, get a view response, communicate back to the requester, and the requester will then, as you can see in the step 8 on the bottom figure, will submit it to its network validation. That part is not going to be standardized; it's behind the gateway. So the part that we want to standardize is highlighted in yellow, just like we did for SAPI core. So what we want to do is we want or we need a universal communication format and mechanism for applications that rely only on gateways for message routing and to trigger network actions. And we want to standardize addressing. We want a structured way to describe state that is agnostic of network or asset types, and we want to show that a general purpose request response protocol is possible, that is does not care about what DLT stack the respective networks are built on. So the data structures that we want to standardize are listed as the API, which is gateway to gateway and client to gateway. I think we have the same scope for SATP core as well. The client to gateway is something we're just in the process of brainstorming, but gateway to gateway is what we have already spec'd out in SATP core. And we also want to consider other like policies, like access control policies and view verification policies. It's something that's described in the views draft right now, but we can discuss whether or not that is within the ambit of standardization. So I think I'm done with that. Yeah.
All right. Thank you, Rama. We probably have time for one question or so. And you already have a draft. It looks like there's a few view drafts. Do you know which one in particular documents what everything you just said?
There are two drafts. If you go to the slide 1, there's views, addresses, and there's data sharing.
All right. Thank you. That's perfect. Anybody have questions for Rama? All right, hearing none. It's good we have a good start on things that might appear in the charter as soon as we're done. Okay, thanks, Rama. And that brings us up to implementation guide. So Hajin. Can you hand him this clicker?
Yeah, hello. Oh. Hello, I'm Hyojin from Seoul National University, and I'm
Move the microphone up a little bit.
okay.
You have to get pretty close to it. Thanks.
Okay. And I think Thomas and I are the only people on site, so I hope the other presenter, Rama and Dennis, I could meet you in person at next time. And yeah, so today I'm gonna talk about the ZP implementation guide, and I participate ZP working group last November for the first time in Dublin, and then I tried to add some my experience to the draft. So I introduced the stuffs. Motivation, which means, in other words, a problem statement. I have experienced the Korean CBDC pilot project last year, and where I developed some of the cross-border payment system using Kaktai open source. And during the POC implementation, I had some problems and struggling with some uncertainty about how to enable comparable communication between entities involved. So let me show the example. So the green box shows the coverage of SAPI core interface, but when I work with the project, I need to consider the other interface, which is uncertain or undefined interfaces. For example, setup stage introduced by Dennis for a while, it requires all the flows other than the green box. So, but it could not be covered as standards because it depends on several use cases or connected network. So the SATP core draft provides 14 APIs like this. So I would like to figure out the two problems here. First one is about the inconsistent or non-interoperable APIs. From the experience of the development, there are some inconsistent situation between SATP standards and implementations, and as well as non-interoperable API situation between several SATP implementations. So it could be covered as the work item of the draft SATP implementation guide. And the second problem is about informal and supplement APIs requirement. So I'll explain further things on the next slide. So this is the proposed contents of SATP implementation guide draft. Regarding basic implementation guidelines, for example, there could be a message format encoding situation between several SATP implementations. So if it's different, then it might not work from each other. So yeah, maybe it could be covered by setup stage though, but we have several kinds of implementation guide requirements here. And regarding second one is about the requirement of supplementary APIs. So if we could provide some example code as sorry, as per the use cases, then the real implementer could be very helpful from this guideline. And third one is about the conformance test suite, which could be provided as a lightweight library, and it plays a role as a standalone gateway that can be verified against the real counter gateway. So it's the common situation in WCC when I work with, but I'm not sure IETF is the common about the conformance test suite, but it would be very useful in terms of the real implementer of the SATP. This slide shows the latest update of the version 2 implementation guide draft, but I skipped the details. But if someone has some questions or proposed candidate content, then feel free to let me know about it. And future plan, I listed some of the candidate items here, but I guess it requires some much effort. So hopefully the implementation guide draft could be one of the official working group draft in the near future. That's all for the slide. Thank you.
Okay, thank you very much. Are there any questions on the floor? I don't see any. So I have one, which is one of the hard things of an implementation guide is what's needed just as hints to implementers versus what is missing in the core protocol.
Yeah.
And my guess, Thomas, is that as the first implementations of all of this go out, we were going to do a biz version of the RFC at some point. Unfortunately, this is a brand new protocol, and it's very expected that as early implementations come out, we'll get a lot of lessons learned, and that's okay. But when you are working through an implementation guide, it would be good to think about, no, this really can't be understood without changing sort of the core document.
Yeah.
So, yeah, please, Thomas.
So some implementations, like in Cacti, it's ahead of ahead of SATP core. So correct me if I'm right. In my mind, so long as the behavior is the same, the actual name of the RESTful API in the source code may be different. Is that okay? Or
No, it is, and in fact, that's what we call bringing running code to the IETF, right? Where afterwards we standardize it, and there's long histories of that actually being more successful a lot of times than trying to define the protocol in the working group itself. I mean, Quick is a good example of that. Of, Google brought Speedy to the IETF, and it changed a lot over time, but all the implementations changed with it, and that's fine. And there's a bunch of examples of that.
So here, Jin, we could have a section saying, okay, if you're looking at Cacti, this is what the APIs are called. If you're looking at Quant's, private implementation, this is what they call it. It's the same thing, but slightly different words, right? Yeah.
In the long term, the goal is to standardize those so that that mapping table isn't needed, and the sooner the better. Yes. So
I thought the current standards and implementation could be an early stage and in progress. So yeah, I thought it could be adjusted for the time. Sorry. Okay.
Okay.
Thank you.
Thank you very much. Ned, did you have a question for Haijing, or you?
I was just going to ask if there's ways to standardize APIs, and so you could look at like an open API and so forth for standardizing RESTful interfaces and that sort of thing. Is anyone looking at that level of definition for implementations?
If anybody has an answer, you're welcome to give it to Ned. I don't have an answer, so not yet, I think. But that's a good suggestion to look at that kind of model.
Okay. Thanks.
All right. With that, Thomas. So I got the agenda wrong, and I put Thomas should have been first, but that's okay according to the published agenda. But we're fine on time, so don't worry about it.
2 minutes because I want to give time to Ned and also to the Eric on the asset exchange. So we've uploaded a new draft. It's draft 00. It's missing a diagram, but the motivation for this work is that as we were talking to people outside the IETF, there's terminology that they use that we need to capture, number one. And then as we go along, this new terminology that we're introducing, like before the artifacts registry, that word did not exist. We weren't using this word 18 months ago. And so let's just put everything in this sort of document that's relevant to SATP, that's a complement in addition to existing terminology documents from NIST. There's one from ISO. So when people look at SATP gateways, they could look at this document, because SATP gateways would not be explained, say, for example, in a Swift ISO document. So that's kind of the purpose. And there's a diagram.
I'm sorry.
Move forward.
My
yeah.
bad.
So just quickly, take a look at the slides. There's this layer diagram. What we're trying to do is understand what pieces are what, because we're talking to each other like on Zoom, like, oh, we're going to do this smart contract. And then we're like which smart contract? So it turns out there's this concept going around that maybe the token should carry its own inbuilt. The token definition should have its own constructor file, constructor function to allow it to instantiate, the smart contract, et cetera, et cetera. That's one model. And then people say, well, the gateway itself might need to do stuff like the views. A gateway should be able to do views, should implement views, or knows how to call into a views function. So we're trying to collect this together because it's pretty messy. Again, it's only draft 00, and please review. It's pretty quick read, and we're just going to add more stuff. If you have specific terminologies, put on a mailing list, and we can add this. Okay, I'm going to stop there.
Well, hold on.
Okay.
Any questions?
Any questions?
So let me start with one. What do you think is the long-term usage of this document? Do you think it'll turn into an RFC or get put into documents, or
it could be? So if it's useful, we could make it an information RFC. Actually, the question I had for you is, we have existing terminology in core and architecture. Do we leave those there, or do we put it here?
Well, I mean, we're going to publish those soon, so
Okay,
I
so
wouldn't
leave it
delete
there.
anything
Sorry.
out of what's needed now. But and we have sort of long-term documents that we long-term drafts that people publish for a while. So,
So
okay.
really the purpose now is clarifying people's thinking as we're talking on Zoom, literally. We're talking past each other. This is the purpose.
One thing you can do for new documents is point at the other internet drafters just to say, this is the terminology we're using across these drafts as they're developed, and then pull the terms into the documents that are needed when you actually publish those documents.
I'll
So,
just copy it over.
thanks.
Okay. Had a question. Rama, you have a question?
Yeah, just wondering, I mean, what...
Too loud, Rama, too loud. Back off.
Apologies. What's the life of this kind of document? I think, I mean, we create such a document now, and later, if we think of some terminology that was not included, can be updated, or do we publish a new document, new terminology document?
Any of the above.
Any of the above.
So if it gets published, if the complete set of terminology gets published as an RFC, it's actually really common to keep updating RFCs. The DNS terminology document, I think, has been revved 4 times at this point with 4 different RFCs. So there's precedence for doing that, but it's important to have the terminology in the RFCs that are actually published. Don't ever reference a publishing RFC to an internet draft. That doesn't work well. So you can always copy pieces into the documents you need.
So Rama, the other need maybe more outbound. So as I'm talking to different organizations, the EEA, Enterprise Ethereum Alliance, a lot of layer 1 guys, layer 2 guys, they're like, where's your terminology document? Here's ours, where's yours? And so this is the other, it's like, here, read this. Is kind of useful, function, useful purpose of this document. Okay.
Okay.
Thank you.
Thank you, Thomas. And all right, Ned, I will pass you slide control. You should have it, so fire away.
Okay, great. Thanks for taking some time. So what I'm going to talk about is a SATP VLEI binding. VLEI stands for Verifiable Legal Entity Identifier. I'm starting with the architecture as an overview, just to make sure I have the same context that others have in terms of how to perceive the architecture, and some of the terminology that's in the various specs that I'm reading are used, but not in some of the diagrams that I was looking in the architecture. So I'm just kind of filling in some of the gaps there. So it wasn't clear to me, for example, where the asset, who owned and controlled the asset. So it seemed like maybe it was owned and controlled by the network owner, but based on some of the chat earlier today, that may not be true. As well as, there's some state information, and it looks like, both gateways maintain some state, as well as there's use of terminology like originator, beneficiary, but those are referring to some kind of domain, I think, in terms of organization boundary or geopolitical boundary, or even possibly network boundary. So it wasn't entirely clear to me how we draw the boundary lines. So I'm making an assumption that anytime I use the word domain, I'm referring to potentially any of the above types of boundaries. And then just to review the phase 0 objectives, I've listed them here, but the main focus that I think are addressed by this proposal is to provide context for asset ownership, which feeds into the ownership validation objective, and authorization context, which feeds into that authorization to transfer context. And it may address some of these others as well, but those are the main 2 that I think I'm interested in addressing. So in terms of entities, just to highlight what some of the entities are, there's the originator beneficiary entity. In the context of the VLEI lexicon, there's a notion of a legal entity. And so just to be clear, it appears as though the originator beneficiary are legal entities from the perspective of VLEI. So that they would refer to that as the entity that's financially and legally responsible for actions of the domain. Then there's mention of, so I've introduced the term orchestrator owner because it seems as though there is some entity within the domain that is orchestrating the asset transfer or the asset exchange in some way. So I'm introducing the term orchestrator. It sort of maps to the client app. So I'm sort of projecting the orchestrator role onto that one for lack of any other entity that's in the architecture, not already called an orchestrator. But in the context of VLEI, there is a legal entity that's responsible for the orchestration and management of the asset. Then we have the network owner and gateway owner. These are also legal entities. The idea is they're responsible for the operation of the network and operation and management of the network, and likewise operation and management of the gateway. Then there's the orchestrator node, which is the host that controls asset exchange or orchestration, and the network, which is also a host. This would be network 1 and network 2 in the architecture, as well as gateway 1, gateway 2, which are hosts in the network that are actually performing the asset exchange. And I've included a definition for legal entity here just so that everybody's on the same page. But the idea here is a legal entity is some entity that's legal or financially responsible for the actions of the domain and the transactions. It explicitly excludes natural persons, which would be humans, except where those people act as a sole proprietor and that has some recognized legal context. So like the CEO of a corporation has a legal fiduciary responsibility, and so that human could be regarded as a legal entity.
So can I ask a question at that stage before we go on?
Sure.
So one of the things that I've wondered since the start of this group is, we refer to legal entities a lot, or we've always hinted around it. My hesitancy is, does that really map to everything that could possibly be using this protocol? So for example, if a person stranded on a remote desert island, happened to own a digital asset of some kind, does that fall under the definition of legal entity because they're still the owner, even though there's not a legal framework that they exist under?
So if there's no legal framework, they're just running a server, then no, there's no. So if the question is about what's the definition of a legal entity, and there's an entity that's on an island operating a server, independent of any other infrastructure, then I would say that doesn't fit the definition of legal entity. So there has to be some legal framework or context in place in order for it to be, in order for you to apply the word legal.
Right. So that's part of my concern, right? Which is, if for the protocol to be generic, we need to make sure that we're incorporating all of those potential use cases, including the server on the remote desert island that's not part of a legal entity, right? They might want to. So do we want to use the phrase legal entity, everywhere, or would something like entity or something like that be better? So not a lawyer, right?
Yeah, entity would be better. That would make it more universal. It implies a clear definition of entity. Yeah, and I'll have another slide on this a little bit later that maybe helps clarify that. So here's kind of the rundown of, in the context of VLEI, there is a hierarchy of roles and entities. And so this is just to walk through what those are a little bit. So think of this as just an introduction to VLEI. So at the top level, there's something called the Global Legal Entity Authority, which manages a root namespace. And today there's only one, and that entity is is GLIFE, which is it's a global legal entity identity foundation, something like that. Okay. The duties here is that it manages this globally rooted LEI namespace, and it issues something called the QVI authorization credential. A QVI is a qualified VLEI issuer. It's an accredited legal entity authorized by GLE by GLIFE, and its main duties are to issue legal entity credentials, or LEIDs, to organizations. So think of it in terms of, hey, I want to do business, and to do business, I have to give that business an identity. There's a way to do that called an LEI is sort of the format for that identity, and then VLEI is providing the credential wrapping around it. So now you have a bunch of organizations with legal entity identifiers. So they're the holder of that identifier. Their main role is to just to be a credentialed organization and to operate in the context of that legal framework. So think of that as the domain, on the previous slide. So it's like once you have an LEID, you're a credentialed organization and you can do stuff. The main role of a holder of an LEID is to issue additional the other credentials, like there's something called an official organizational role credential and another called an engagement context role credential. And that's the main goal is to issue these other credentials, which have to do with sort of the operational aspects of that domain. As an aside, there's some additional detail here for a delegation to happen, so that LEID entity could delegate the issuance of these credentials to some other party using this delegation credential. So it would allow an organization that was Spartan and didn't want to wanted to minimize their costs for operating, they could delegate to some other entity that's specializing in issuing those types of credentials. The OOR credential is essentially a credential that binds an individual to a position or role, such as CEO, CIO, whatever. It acts as an official persistent capacity on behalf of the organization, and issuance of the OOR credentials may be delegated via an OORA. So this is sort of a side of credentialing for organizations, which is not really talked about in any of the SATP documents that I could find, but likely that context exists in the real world. But I don't know that it really is significant with respect to influencing the SATP protocol. But that's TBD. I don't fully understand what is involved in the stage 0 exchange either. The one that's most relevant is the ECR credential, and this is essentially saying, hey, there's a set of people who have operational roles who are going to sort of manage the life cycle of the various hosts in the domain that do the actual work. And so that credential is essentially the one that authorizes the issuance of these other credentials. I'm going to talk about that in a minute. So just to give you a high level view of how this fits together, there's sort of this hierarchy of issuance. It looks a little bit like a CA hierarchy, but it works differently. It's not based on certificates. But you can see from an authority perspective, you can see there's some hierarchy of authorization behind the credentials that are used. And so probably the important thing to note is this last bubble called device credential. There's the ECR credential, which is a VLEI credential. Then there's the device credential, which could be some other credential. I'll talk about that in a minute. So from the perspective of trying to tie in some terminology that's used in this draft with terminology in other SATP drafts, there's some use of owner in some of the specs, but it's not really clear what that means. So I've created things like orchestrator owner, network owner, gateway owner, as it's implied that these entities exist, but it's not really called out anywhere. All right, so here's kind of the slide that completes the architecture. So you have this VLEI framework that sits on top of an organization, and then when you get to sort of brass tacks, there's the various hosts that are performing the various steps in a SATP protocol. So you have this orchestrator owner, which is going to issue some credential to the orchestration host, which in parentheses it looks like it might be the client app, although I don't really know if that's the correct way to stereotype it. Then there's a network credential for the network host and a network owner, which is issuing that, and so forth for the gateway. Of course, these could be combined into a single entity in an organization. I'm just showing it as they could be separate as well. And then the credentials that are issued could be of any type. So it could be a PKIX, certificate, an OAuth2 token, maybe, but it could also be like a carry key event log. And I'm going to talk more about what carry means in a second. Or it could be a ticket, a Kerberos ticket. The idea is there's some kind of artifact, certificate, token, event log, ticket, whatever. There's some kind of artifact that represents the issuance operation and provides some approach for verifying that issuance step happened. The current draft talks about carry and probably PKIX credential types. Right now, it just says other in some of the places through that, but that's just a placeholder for deciding on like what are the other ones that are most relevant. And certainly, reading the various drafts that are there, it seems as though it's assumed that certificates is used, but it doesn't say if that's exclusively the case or if there's if any of these others could be used at some point. So that's that. If there's any questions, I'm going to just keep moving through this. A lot of this is just kind of context to set up so that we can have a conversation later on other stuff. So here's some background on key event receipt infrastructure, also known as carry. The basic kind of concepts here are that carry is basically establishes self-sovereign control of an entity that's a key wielding entity. So I might use the word principal in my conversation to refer to any entity that wields a key. And so carry refers to them as just entities, as self-sovereign entities. And in that context, there isn't a central authority that's vouching for the entity and their key pairs, the way that you would have with a certificate authority infrastructure. Trust in a key is determined by evaluating its key event log. So this is actually a form of key attestation. If you have followed any of the other work that's going on in the IETF around key attestation, it's basically trying to provide some context around which the keys are controlled and protected and so forth. So and think of a carry event log as providing that. Some of the events that would go into a key event log are an inception event, which is essentially the epoch event, and that inception event identifies a bunch of state. So it identifies the keys, which sort of the current keys being used, but it also identifies pre-rotated keys. And it also identifies the various entities that are used to publish and verify the key state, along with some configuration data. So from the perspective of managing the life cycle of a key, there's a lot of information in the carry event log that describes how that life cycle management is supposed to happen. Interaction events are another type of event. It's basically something that associates application data with key state. And so in that sense, you're binding application data with the key state context. It sort of feels like a certificate in that sense, where you have a certificate is associating a public key with an identity and then some other data in the form of certificate extensions. But it just does it in a different way. It's based on a sequence of log events as opposed to kind of a one-time issue certificate event. Then the key event log is as a log of events. It's also digitally signed, so you can think of, in some sense, you can think of each event in the log as being sort of like a certificate. It's sort of like a self-issued certificate. But it might confuse people if you use that terminology. Verification is really the process of doing of evaluating the events in the log and making sure that the signatures check out and that the association of the data with the key state is appropriate and meaningful. And there's an infrastructure for how to do that. And that infrastructure is distributed. Then there's the notion of a VLEI. So a VLEI is a type of application data, if you will. It's called an authenticated chain data container, or ACDC. And it's just a way of binding application data to key state. So there's some structure around it. And VLEI extends that structure to address the specifics of the authority hierarchy that we just went through. And so the basic idea here is that the binding of the application data, which in this case, the ACDC, to the key state is really what the basis of trust is in the data. So that was really a super quick tutorial for Carrie. If you have any questions, let me know, but if not, I'm gonna just move on to the next slide.
No hands so far.
Okay, so let's talk about kind of what the VLEI binding to SATP really boils down to. There's two objectives here. One of them is to essentially, bind, as kind of described earlier. It's being able to follow this VLEI credential issuance all the way down to ground to the various hosts that are actually doing the real work. That's part of the binding. Another part of the binding is to be able to identify the SATP payloads in the various that contain VLEI content, and so a goal here is to reuse IETF techniques for doing that, like media types and content format identifiers, to just say, hey, here's this SATP payload for whatever message we're talking about. When you crack that payload, when you get to the part where here's the payload, that payload could originate from somewhere else. It could be defined by some other spec, and there ought to be a way to identify that content before you crack open the payload structure. So it's just saying, hey, let's use the media type structure for what it was intended for. In terms of the initial target for this draft, it's targeting phase 1 structures. And so within that, there's a set of messages that sort of are all public keys in one way or another, or their identifiers. And so we have the originator public key, beneficiary public key, sender receiver gateway signature public key, etc. So it implies that these are public keys of some form or structure. In the context of a carry infrastructure, it might be more than just a public key. It's actually, what really counts is the the context at the inception event is really what's meaningful, as opposed to just the public key or one of potentially multiple public keys that are part of that context. So it seems like there's a need here to just be able to define, for each message, be able to say, hey, this is actually containing a payload that is richer than just a public key. Similarly, for the identifiers, there's a bunch of identifiers, and so that it assumes there's some sort of format for the identity, but it's not really specified in the protocol as far as I could find. So that's another place where it makes sense to kind of have some kind of a wrapper function with a content identifier in it. So this is what I have so far. This is CDDL representation of a wrapper that has just content payload as the basic structure. And so the content then is based on existing media types or content format identifiers, and OIDs. So you could have a sort of a string representation of an OID as an identifier as well. If the content happens to be CBOR, then there's sort of two flavors of CBOR. You could have just naked CBOR, you could have a CBOR tagged CBOR. So if it's a CBOR media type, then you might want to set the Boolean to say whether or not you should expect a CBOR tag before the actual CBOR data. And of course the goal here is to say, just take this wrapping function and essentially put it around all of the different phase one message types that I've listed above, and just say, okay, for every one of those, there's this convention for wrapping the content with the content identifier before you get to the payload. In the context of media type definition, it anticipates reserving a few additional media types. Here, application Caesar. I didn't talk about what Caesar means, but basically, if you're talking about an AC/DC structure or a keylog structure, they're typically encoded using a Caesar encoding mechanism, but the Caesar can also represent JSON, CBOR, and message pack as well. So there's ways to represent a variety of different types of data, and so these four are proposed. It also proposes the definition of an optional parameter called a profile, and this is where we would use like a URN to identify that this is something that's VLEI specific. So if we're talking about a structure that is a QVI credential, then you can populate it with populate the profile so that it's clear that this is the type of content is a QVI content, and that can help parsing. So now to open issues. So first issue is in the SATP core, it doesn't appear to handle the message payloads that are originating from the outside. So VLEI is an example of an outside format. So does it make sense for the SATP core to define something like this artifact wrapper, or does it make sense to just have it be specific to, say, VLEI? And I was just, when I read through the specs, it wasn't clear to me. There are lots of examples of, hey, it could be this kind of structure, that kind of structure. And then there's some examples of, if it's a particular type of structure, here's how you might do it. I couldn't see where there was a solution to the problem of, well, what if it's multiple, and how do you keep from, how do you inform your parser what to expect without actually parsing it? So that seemed like an issue maybe with the core spec, and so I'm curious to know kind of what the current thinking is on that one.
Well, why don't we stop here for a bit? We will run out of time, so I want to make sure to give Alex his time on his agenda item. I think it's critical that the SAT protocol can be flexible and accommodate, the extra information that might need to be passed in certain contexts. And Thomas, I'm going to look at you and see if you have. I was waiting for your hand to go up.
Sorry, hands up. So now Ned and I have been going back and forth. The message payloads for originating from our side. Yes, we could look at that. Yeah, public keys, particularly how to process keys and so on. That's like out of scope for us. I mean, we never, because it's just between the gateways in the yellow bit, right?
It is, and not only that, this is one legal context framework, as I sort of hinted at before, right? And so how do we make the protocol extensible enough that when two cooperating parties, want to talk in a context they both understand, that they can pass the needed information across, that is supplemental to the core protocol to make that, possible.
The third bullet, Ned, the third bullet is actually very interesting. So gateways could talk to each other and walk through their logs to figure out if, G2 trusts G1 and vice versa.
Yeah. So I think there's a whole bunch of conversation that we could have around how to integrate at phase 0. How much state, like a lot of the phase 0 is about establishing context and verifying context. A question to ask is how long does that verification context supposed to live, recognizing that you can get a cert report anytime, and that could call into question any sort of cache state you have about do I trust this, or has this been verified, right?
Yeah, no, that's a good question. I mean, the gateway operators are long-lived. It's a business. It's like an ISP. The banks, if it's traditional banks and the RTGS system, that's long-lived. They have their own big identifier thing that they could put inside a VLEI. On the other side, the originator beneficiaries could be individuals, Ned. It could be like persons, Alice and Bob.
Mm-hmm.
Right, and so the one that I'm scratching my head right now is the orchestrator, because if one or both are DLT, the DLT doesn't really have an orchestrator. You know what I mean? Maybe the gateway also acts as an orchestrator.
And like I said, I kind of made that up because I wasn't sure what assumptions were being made about how all of the activities of the domain get managed in a consistent way.
Yeah.
Right?
Yeah, this is all stage 0 stuff. So actually, I would think that the client app 1 and app 2 together are the orchestrator, because they have to somehow sync before we even get to line 1 or stage 0.
Right. Yeah. And it wasn't. I mean, it's still putting it together. The stage 0 stuff's just starting to be defined, and so I don't know if there's arrows between the app 1 and app 2 in phase 1. I don't know. But the point is, there's a bunch of context around authorization, and maybe I'll skip to the next slide, which is the last slide. There's an assumption about the context between both entities that is the basis for establishing authorization and ownership of a variety of things. And so, from the perspective of a VLEI, they are defining the context for ownership and authorization of stuff. And so it's important that the protocol be done in such a way that that context gets preserved. Ideally, it doesn't get mapped to something else that's, a lossy mapping of the context. And that would be my most, that would be maybe the major concern from an architectural perspective, of being able to put these two kinds of technology together.
Okay.
But this is an adoption call. I don't know if we have time to talk about it, but I'd like to move forward with this.
Okay. So as I mentioned at the beginning of the meeting, we need to recharter, and this is on sort of the charter items that people sort of wanted to charter next. But so once the existing documents get passed off, we can consider adoption. We can't do it yet, though. That being said, I think it's an important information, and I'll just close with one final comment, which is that the IETF doesn't define, legal constructs in our protocols, right? We create protocols that are open and generic and anybody can use in any context. And that means that legal entities can use the protocols to communicate, but we don't necessarily want to get into the game of encoding particular legal entities and contexts into our protocols, and this is how this system works, right? There needs to be a line between those two sort of notions, and I think that's a good mailing list discussion to bring up. But thanks, Ned, for bringing this whole topic to the new topic to our awareness. And with that, I think we need to go on to the next presentation. Sound good?
Yep, thanks.
All right, thanks for presenting. All right, so next up is the Secure Asset Exchange Protocol. Alex, I will pass you slide control. You should be good to go.
Okay, awesome. So yeah, we talked a lot about SATP this evening, and this presentation will aim to look at future work. So expanding the protocol to also support an asset exchange. And what do we define the exchange as? So if we look at the previous scope that SATP had, develop a protocol for the secure one-way transfer of any digital asset between networks that is agnostic to both the technology of the network and the nature of the asset. Well, for the asset exchange, we want to expand the SATP protocol for the secure two-way transfer of any digital assets between networks, agnostic to both the technology of the networks and to the nature of the assets. So in many real life use cases, a transfer of an asset is great, but we want to actually exchange goods. We typically you would have a digital asset transferred for some sort of cash, or it could be a tokenized deposit or GBTD or yeah. So when looking at the motivation behind us starting to look at secure asset exchange and the problem statement, the existing protocols handle authentication and authorization, not asset level exchange. There is no standard mechanism for verifiable confidential transfer of digital assets between independent parties. So there have been many applications representing bridges between networks for asset exchanges, and we've also seen decentralized exchanges running between networks. But there's no standardized model of implementing such an exchange of assets. So there's also ad hoc solutions create interoperability gaps, security risks, and trust fragmentation. And the secure access exchange protocol would provide a common secure framework for exchanging digital assets over existing IETF infrastructure. So building on top of what SATP already defines, and yeah, just extending the existing protocol. So some of the design goals we've had: security first. We also wanted interoperability, extensibility, so modular messages, types, and exchange profiles, just building on top of the existing message flows. Minimal trust assumptions, so no central authority required, although the gateways themselves need to trust each other, just like in the original SATP. And also the protocol clarity, so define semantics, deterministic behavior, testable implementations as well. So all the messages have the examples as well in JSON, and yeah. So brief architecture overview. We have the initiating gateway, the receiver gateway, and the respective asset networks. So nothing changes from the architecture of SATP 1. I mean the original implementation of SATP or definition. So what the secure asset exchange protocol looks at is just the communication between the two APIs, API 2 that you see in the diagram over here. So the communication between the gateways, and yeah, everything else is supporting the use cases or any business applications. But yeah, the asset exchange protocol would refer only to the communication between the two gateways, G1 and G2. So for the protocol flow, it follows the similar pattern that we've seen in SATP. So we have the three stages: the transfer initiation stage. So here we have the agreement of the set of parameters describing the proposed exchange. So the gateway initiating the exchange delivers the initial proposal containing the set of parameters, and it agrees it with the receiving gateway. Then there is stage two, so the lock assertion stage, where we have the conveyance of a signed assertion to the receiving gateway, asserting the lock status of the asset and network connected to the initiating gateway. So here, just as in SATP, we have the lock assertion of one side, one leg of the exchange. And then we have the commitment preparation finalization stage. So conveyance of assigned assertions to the initiating gateway, asserting the lock status in the network connected to the receiving gateway. The gateways finalize the exchange by assigning the assets to their beneficiaries and convey signed assertions reflecting the corresponding statuses. So in stage two, we have the locking of the initiating side. So the asset on that side is locked so that we can prevent double spending. And then in stage three, there's the locking on the receiving end of the asset as well, and then transferred to their respective identities once both locks are in place. So following a similar two-phase commit protocol, just like SATP. And yeah, that's about it from my side. Pretty short, but just looking at some next steps over here. So the current status, draft 00 is available. So I encourage all of you to have a look. It's already on the IETF data tracker, secure asset exchange, and yeah, there's also reference implementations in progress. So I think Rama already mentioned Hyperledger CACT implementation, and Quant also has their own implementation underway. So for the next revision, we want to refine message syntax and error handling. And also then we have some key open questions. I believe this is the first time we're presenting this future consideration. And yeah, we still very much want to align with the initial direction of SATP. So we want to check if the IETF is the right venue for this work and if there is a clear problem being solved, and having interest and potential implementations. Also, we might need some help regarding the naming. So we have secure asset exchange protocol, but of course, if this is going to be an expansion on secure asset transfer protocol, do we just keep it asset transfer with an exchange side or option in the protocol parameters? So yeah, we'll be looking for a bit of help with that. And also, if it's worth it having its own separate document, or if we should just include this in future revisions of SATP core and architecture itself. So yeah, looking forward to seeing all the discussion on the mailing list, on all the use case alignments that we have, and also on the design assumptions. But yeah, thank you all for listening, and we've got a bit of time for any questions and answers. So please and thank you.
All right. Anybody have questions? I mean, with respect to is the IETF the right place? It's a follow-on in the SATP work that we always envisioned would eventually come about. We had just tabled it as I should say the IESG gave us explicit guidance at the time that they didn't want us to do too much in the first time. So we restricted ourselves to a unidirectional transfer with the likelihood of extending it to a bidirectional transfer in the future. So, as a chair, right, my opinion is this is the follow-on work to the existing body of work, and it would probably rev the existing one. But having said that, you would need to tell us, is the existing protocol extendable in a way to make it happen? Or do you actually feel that, it's actually incompatible? I hope it's the first, but I wouldn't rule out the possibility that it doesn't work, without something brand new. Does that make sense?
Yeah, definitely. Yeah, exactly. It is accessible, so it aligns perfectly with our definition of SAEP at the moment, and it just builds nicely on top.
Okay, with respect to so whatever protocol ends up, right? Both cases need to be supported. You know, you need to be able to send something to somebody else without the expectation of a return, and you need to be able to do a swap or an exchange. Um, how that is done, I leave up to the working group to decide, in the long run, how you want to negotiate that, and is that part of phase 0 where you figure out, does stuff need to transfer in both directions or not, and what bits of the protocol need to modify. That's something the working group needs to work through. But okay.
Yeah.
Anybody else? Aishun? Yep.
Thank you for explaining the protocol. And to review the ongoing exchange protocol work, could I refer to the existing SAEP protocol described in overledger API reference?
So sorry, I didn't quite understand the question.
Yeah,
If you
when I look at the API reference in overledger website and SAEP API is described, so could I refer to the API for the purpose of reviewing your proposal?
Oh, I see. So I wouldn't exactly look there because on the Overledger implementation, as far as I know, the latest release was still an implementation of secure asset transfer, so not asset exchange. The implementation is minting tokens on the destination network and burning a token on the origin network. So just a one-directional transfer. So this is something new, what we've presented today.
Okay, thank you for the clarification.
Thank you. Thank you for the question.
All right. Any other questions? Seeing none, I don't think so. I think that thank you very much for the presentation. And with that,
Thank
I
you.
think that brings us to any other business. And there's 8 minutes left if people have other things they want to bring up. Unfortunately, a number of people have had to run off because we had conflicts with other working groups. So a couple of people had to leave, but they sent their apologies ahead. So anybody else have last minute items? Nope. With that, I think I will give you a whole 7 minutes back of your time. And thank you all very much for coming.